Hi there. So as you can see, I've got the lathe stripped down. I actually took the apron, separated the carriage and the apron, cleaned all that up, learned some things about it, how it's adjusted and everything. So I should be able to take some of the slop out of it that I had encountered. Figured out why my cross slide was had so much play, so I can adjust that. But basically just took the time to strip it all down, give it a good thorough cleaning, removed everything from out of the way, and now the plan is I'm going to install my new DRO. I'm going to install some way covers. I'm going to make a backsplash for it so I can stop splattering the wall, and I'm going to put some lead screw covers on. So yeah, should be pretty nice when I'm done. So let's get started. Alright, so a little update on the progress I'm making. I can't get a camera in here to film any of this while I'm doing it. So when I get to the cross slide, I'll be able to film that. But this is pretty simple. There's nothing really to it. The scale is just mounted directly to the body, the table on the lathe, using the brackets that came with it. Sorry about that noise. That was the automatic drain on my air compressor. I thought I had turned it off. But anyway, yeah. So the scale is mounted, and the reader head, as you can see, is on it. I've got the bottom bracket. I don't know if you can see that attaches to the reader head. I've got the another plate here. The bottom plate has slots in it so that this can move in and out, and then a piece of flat aluminum plate is going to be mounted here to the carriage, and then that'll attach here and it'll be slotted on both sides. So I'm going to make that next, and then after that I will make a couple little L brackets for here that will have a piece of aluminum angle, which I have that right here, is going to go like that and cover up the scale and the reader head to keep chips and debris off of there. That was one of the biggest problems I had with the old DRO. It worked great when it was clean, but it was exposed, and the gear teeth on it, chips would get in there, or even just enough buildup of gunk, and it just would fail. So this should be much better. So I'm going to wrap this up here, and then we'll get on to the DRO for the cross slide. Okay, so we've got the Z-axis finished. As you can see, I've got an aluminum chip guard over the top of it, and it's mounted to the carriage with a couple pieces of aluminum, flat bar, etc. So that is all done, and now we're going to get started on the X-axis scale installation. Alright, to mount the X-axis scale, so a little background first. This slot here, this recessed area you see here, machined into the top of the cross slide, that is where the old DRO scale was mounted. So it was mounted like this. It's not actually attached, it's just sitting there. It was mounted like this, and a rotary encoder was mounted right here, which would read off of this scale. You had to keep it clean though, and that's the Z-axis was failing more often than the X-axis, but it's time to modernize it. So we're going with some modern scales and a Touch DRO system. And the plan for mounting this is one of the longer scales. This is one of the longer scales. I'm not sure that I'll need this full length. I have 4 scales, so we'll see what I ended up using. But for now, just to demonstrate what I'm thinking, this is how I'm going to mount this. So what I'm thinking I'm going to do is mill another recessed area just like this one on this side of the carriage, and the scale and the reed head will be mounted on this side. The reason is that the grub screws to tighten down the gib are on this side, and these scales have to be mounted in this orientation. This one is going to be short enough that it probably wouldn't hurt to do it horizontally, but they need to be mounted vertically, and I'll have more room to do it vertically anyway. So my plan is, let me grab the other scale that I have those brackets and stuff taken off of. So my plan is to make an L bracket that will fit here and come down the side, because I have to have room between the bracket and the cross slide so that the reed head has clearance. So that's first step, and I'm also looking at making that bracket. It'll probably end up sticking out probably just shy of the length of that scale. The reason being is that the reed head is going to have to be mounted out here where there's clearance, because the reed head needs to be mounted to the carriage. So in order to have enough room for travel, I need to have the this mounting bracket quite long. And then the scale will be mounted to the bracket, approximately something like that. Move my chewed up hand here. Approximately something like that. And then I will have, so this will have a piece sticking up. You'll have a similar piece up on this side, also right the same length. And then I'll make a cover that comes over this way with another L coming down to come over and provide chip guard and cover up the scale and protect it and the reed head. So that will need to stick up enough to clear the screw, the nut here, adjustment. Originally I was thinking of cutting a hole in that plate to access this, but the more I thought about it, all I have to do is remove a few screws and I can get access to this if I need to, which I don't need to very often anyway. One of the other advantages of doing it this way, there's 2 other advantages of doing it this way. I'm going to use some steel to do this, and it'll be painted the same color as the lathe, which, thanks to my buddy Joe, who actually was the one who painted this lathe originally, he had some leftover paint that he gave me. But the other advantages to doing it this way are that I get a flat surface here that I can put a mag base on. Right now there's very little flat surface anywhere on this lathe. Even this, although it's relatively flat, with the screw sticking up here, it always interferes, so there's no room. So that'll give me a nice flat surface to put a mag base on. And as you can see, when the cross slide is pulled all the way back, it leaves quite a bit of the screw exposed. So this, by having that stick out like that, will provide cover for that screw. So that's the plan. So let's get this cross slide over to the mill. And the first step should be relatively simple, which is mill another slot like this. Now, one thing that's going to complicate that part a little bit is that when Joe installed the DRO on this that he designed and built, he cut this to match the profile of the circle here. I'm going to attempt to do that as well, and I'm going to attempt to make my cover that same profile, so that it looks nice. One other thing to note is that yes, having that cover on here is going to increase the height of this, and it's going to decrease the amount of clearance or space I have between the spindle and the top of this. However, I believe that I can get by with going no higher than the top of this piece anyway, which is only what looks like quarter inch. So I don't think I've ever been that close on cutting anything over the top of the cross slide anyway, so I think I'll be okay. Anyway, alright, so let's get over to the mill, get this mounted on there, and dialed in as far as parallel to the table, and mill this piece down. So it is kind of scary, but on the other hand, I have a spare one of these that if I screw it up too badly, I can go to my spare. But I only have one spare. Alright, so let's get started over at the mill. I've got the cross slide mounted to my fixture table, my fixture plate. It's clamped down in 3 spots, and there's pins on the back to align it to the fixture table, fixture plate. So it's good, it's not going anywhere. And then I've got a 3/8 high-speed 4-flute end mill. This is cast iron, so we'll give this a shot. I'm going to zero out my quill DRO at the depth that I want to cut, and I'm going to come in. Let me see, how do I need to do this? Okay, drop this down. Oops, sorry. Gotta move the camera. wanted to turn the quill so that the end mill is oriented. None of these dimensions are critical because it's all going to be covered up anyway, but I want to make it nice and look the same. Alright, so I've got my Y zeroed out. Now I need to measure how deep I need to, by deep I mean width. I need to cut over here. Alright, I measured, and this cut is a ½ inch, which is what I expected. So let's cut this thing. This down. There. Now let's take this in. There. Good enough. Let's lock that. That down, 0.127, 0.12, and I'm going to cut this part off first, off of this raised part. Grab my safety goggles, safety glasses. Okay, here we go. Yeah. See how much of a mess we make. Yep. I'm going to get the vacuum hook up. I made this thing specifically for when I cut cast iron, and if I don't use it, I'm just stupid. So, sorry, but there's going to be a lot of noise going on because of the vacuum. So I will most likely cut the sound during editing. I'll be right back. Okay. A little bit of touch up there with a file. I think that'll be all right. Paint. Get something sharp and cut that off. All right, the next step is to drill these two holes that will be used to mount the bar to the cross slide. So I need to figure out what size those are and where those are and drill and tap those. So I'll be back. Alright, so I've got the workpiece cleaned up. I took off the clamp that was over here so I can get easier access to these two holes, which you can't see. Sorry, these two holes here. First I want to check and see what size they are, what thread. So to do that I'm going to use this set here, which I don't know if it's been on a video before or not, but these all came strung together. You can see the hole in it. Every one of them has a hole, all strung together on a wire cable, which for some shops, you know, mechanic shops, things like that, would probably be good, but for me it was just a pain. It was always in the way. So I cut the cable, took them all off, and 3D printed this little tray to hold them. This works much better for me. So these are nice because they've got, on the one side they've got the female, and on the other side they've got the male thread, and they're not intended to be thread gauges or anything. They're just to tell you what size it is. So let's see, let's start with 832, I think might be. Yeah, it's bigger than that. So number 10 probably. So probably a 1024. Well, it starts, but it doesn't go. I wonder if Joe used a 1032. Oh, yep, there it goes. 1032. Okay. So I want to use cap head, Allen head head screws, counterbore down in the metal, that the rails that's going to go here. So I'm going to go over to my hardware store and see what I have. Alright, so this is my hardware storage drawer. See what we have here. So I said 1032. Yeah, looks like I've got plenty. Everything from aluminum 1/2 inch, stainless steel 1/2 inch. I have a feeling I'm going to need longer than that, but I've got a good assortment. So 3/4. Alright, let's just start with one of these. For now, that looks like that'll probably be about the right size. Alright, sorry I had to do this off camera. I just couldn't get in there with the camera in the way. So using my Starrett dial approximators with the depth base on it, I just measured from the edge here, which you can't see, from this edge to the screw, added 1/2 of the diameter of the screw. Did the same for the other one, and I know that the screws are centered this way, so they're 1/4 inch in on center, so that should be good enough. And I'm going to set it up and drill those holes and then tap those, and we should be ready to move on to the next step. Alright, I've got the mill positioned on the spot for the first hole. Got a number 21 drill bit in there, and let's drill this hole. Okay, I've got a tap follower set up in the drill chuck, and I'm just going to use a tap wrench, two simple little shallow holes, and they're not through holes, so I don't want to power tap them. But this is one of my favorite tap wrenches. The cool thing about this tap wrench is it has this piece which acts as a guide, and you can use it on a flat surface like this, or you can use it on a pipe, round piece, and it's got access here so you can see and align things. At the bash this year there was a couple of these, I believe, that were included in the stuff that Shars donated for the raffle. This one I got from my dad. All it says on it is model TR50 GTS Germany, but it works great. Absolutely love it. And it comes with a couple different size jaws, so I can use it with multiple different sizes of tap wrenches, of taps. So yeah, so let's go ahead and tap these holes. Nothing magic here. That lined up. Let's move down to the first one. Which was at 0.639. There we go. It occurred to me as I was setting this up that I'm probably not going to be able to use a cap head screw like this. I'm probably going to have to use a countersunk one, because the metal bars that I'm going to be putting here and screwing down to this are all going to be probably around 1/4 of an inch thick, so there's not going to be a lot of room to countersink them. So, alright, let's get on to the next part. I found a piece of stock in my supply that is pretty darn good for the fit for the for the bar for the cross slide, and I cut it to length approximately. Cleaned up the rust on the wire wheel, and now I've got it mounted in the vise on the mill. You know, typical with a copper wire, because it's not perfectly square. This piece of stock is pretty much right at the limits of the longest that I can cut, well, given spindle center to center distances. Obviously if I use a fly cutter it'll increase the cut length, but so I'm going to hook up or set up an end mill and square up this piece of stock, and then start cutting it down to size. Alright, I've got everything set up here. I've got some machinist jacks underneath each end to help avoid some chatter, and this is the first time I'm getting to use my lube cube. It's the first time I've cut any steel on the mill since I put it on. So let's get some eye protection. You're going to have to pardon the noise in the background. That's the compressor running and the air for this. So, all right. So let's see. Let's just try taking off 5 thou and see how it looks. I don't really want to take a bunch of material off. I just want to square it up. Just feeding by hand right now, make sure I get a feel for everything. All right, somewhere along the line there I ran out of battery. So, yeah, we're in the middle of the cut. Just keep going. See how this looks when we're done. We'll dry it off, clean it up, and see how the finish is. So far I'm liking the mist cooler. It seems to be, or not mist, there you go, that's what they claim it's not. Now the air died again. I wonder if my little compressor is just a little too underpowered for this. Sorry, got to pause here for a second, because I just realized I'm almost at the extreme travel on the mill there, but my placement of my machines is such that my handle is maybe 3/8 or 3/16 of an inch away from my shaper. So, got to move the shaper. Alright, I just moved it out of the way. It's like almost everything in my shop, it's on wheels. Actually on leveling casters is what these things are called. I don't get down there if I can show you what those look like, but you can't really see them. Anyway, they are have pads that come down out of the caster that make contact with the ground to stabilize and level the equipment. They're actually made for machinery and stuff like this. So alright, let's get the air, the coolant going again. Yeah, this little compressor of mine, it's only a 1 gallon. I use it for blowing things off. Whoa! Gotta turn the mill on, dummy. And that is pretty much the extent of the travel of my mill, too. One of the questions going through my mind when I set up this coolant system was if I needed a valve, because it's on a quick disconnect. The answer to do I need a valve is yes. I don't want to have to be connecting and disconnecting that coupler every time I need to use it or stop using it. Alright, other than a burr on that back edge and the places where I stop the coolant, like you can feel it right there, and out here where the coolant wasn't running, it's rougher, I'd say that's a success. Alright, I'm going to try it one more time. One more short pass just to clean up, because you can actually feel. It'll be alright. Because it's going to be cut down to size anyway. Alright, so I'm going to take this out, flip it around, and do the other sides and get this all squared up nice. I'll bring you back when I'm done with that. You've seen people squaring up stock before, but I wanted to shoot this and try the lube cube, and I think so far I'm liking it. Alright, so the next thing I need to do is determine how high I need to make that bar, and I think the easiest way to do that is going to be with the height gauge on the surface block. If I can, the surface plate, if my height gauge permits. So I actually have two height gauges, and if I can use this digital one, that would be nice, because then I can just zero it out and get the difference. Yeah, looks like that'll work just fine. Okay, so let's zero this out on the recess. And then measure to the top of the screw. 0.307 we'll call it. I want to check the other side too to make sure they're the same. Four and a half tenths higher on that side. Now I'm reading 2 tenths on that side, so close enough, within a couple tenths. None of this is critical. So what did I say again? 0.3. So let's just call it 0.31 is how thick I need to make the bars across here, and that'll provide clearance for that. Now, after I do that, I'm going to have a plate that sits on top of that, those 2 bars. So I need to make sure that whatever thickness that plate is, it's not going to exceed the height of this. So let's see. Let me get something to write with. I'll be right back. Alright, so if I zero off on the top of the screw, and I go to the top of here, that gives me 0.151. So the max thickness of the plate is 0.151. Alright, let's go see what I've got in my stock. Cover this thing up right away before I do something stupid and set something on it. Any horizontal surface, as they say. I've been pretty good about keeping things covered on this workstation. Alright, let's go check my plate stock. I've got the bar clamped to the cross slide with just a spring clamp, and got some die chem there on the end. It's just about dry, so I'm just going to use a pair of calipers. Let's see if I can get in here without bumping this camera too badly. I'm just going to use a pair of calipers and see if I can trace a good line there for where I need to match this radius. About right there. So, sorry. So let's just there we go. Alright, so I'm going to go chop the majority of that off with the bandsaw, and then I think I'm going to use the die filer and get the rest of it. And hopefully that gives us a pretty good fit on there. And then once that's done, I'll use some transfer screws, assuming I have some 1032. If not, we'll come up with something else, and transfer the location of the holes, drill those, countersink those, and then this part of the bar is done, and I'll be ready to weld a piece on this side for the scale to mount to. So here's the scale. The scale will mount like this on that edge there. So let's go over to the bandsaw. Alright, we're over here at the bandsaw, and I'm just going to chop off a good piece of this stock here and then finish it up on the die filer. Alright, that was pretty easy. That should be really easy to clean up. Alright, let's go take care of this. Alright, I've got a round file in the die filer, and it shouldn't take much to clean up this part. Alright, take it over to deburr it, and let's see how it fits. Alright, let's see how this thing fits. go. Yep. Looks pretty good. It's got a little bit of a gap there because the I didn't mill all the way up to the raised part here, but it's the same on the other side. So maybe what I'll do when I make the top part that goes over all of this to cover it, I'll put a little rubber gasket in there or something. Alright, so let's figure out where these holes need to be drilled, drill and countersink those, and then we're on to the next step. As luck would have it, I do happen to have a 1032 set of 1032 transfer screws, so let's get those in there. Those are bottomed out, so they're not going to go any lower. Workbench is a mess right now because all these projects I have going on. Okay, that should work. Just left to, I don't know if you can see it there. Yeah, there's one. And there's the other. So we'll take this over to the mill and drill those holes and then countersink them from the other side, and we should be good to go. I've got the part clamped down in the vise, and I've got a wiggler installed in the drill chuck. So I'm going to find both positions. I'm going to set them in the DRO, and then we'll drill them and do the same thing again after I flip it over to countersink them. Alright, there's the first point. So I'm just going to set my X and Y at 0 there. Now hopefully the other one, oops, hit my wiggler. Hopefully the other one is lined up, but odds of that are pretty slim. Should be pretty close though. I'd say it's lined up. Alright. Swap out for a drill bit and let's drill these. I think, what did I say? I wanted to drill them up to 3/16. That's a little tight with 13/64. Alright, I am going to spot drill these first. get this part flipped over, and then I will counterbore the other side, and we're making good progress. I really like these Weldon zero flute chamfer countersink bits. They just really work well. Okay, gang, change of plans. Not going to be welding a plate on here. I found in my stash of metal a piece of aluminum bar stock that is the perfect dimension. So I'm just going to drill and tap some holes and attach this with screws to that bar, just like that, using some 440 1/4" countersunk screws. So yeah, that'll be much easier, no welding involved, no have to worry about any more warping or anything like that, and this will be plenty strong for what we're doing. So let's locate the edges on this piece and put some machinist jacks under here. Probably don't need it for little drilling I'm doing. And drill those holes so we can get it tapped. Hi everyone. Well, we're going to bring this video to a close and have to make two parts to it. It's just getting too long, and I'm only about halfway through maybe all of the footage I shot for this project. So yeah, so there'll be part 2 coming out here hopefully shortly.